and I will definitely count it. It won't be anonymous, sorry.
No worries. Thank you.
But yeah, feel free to vote too. Paper or
not small bits of paper. I think maybe if we could ask Gavin to type stuff onto a slide.
yeah, I will type that.
Yeah, do it.
Okay. Sure. So yeah, I think in the planning we have 45 minutes now for a discussion panel and then award ceremony. I'm not sure if ceremony is the right for the workshop, and the closing of the workshop. So what we can ask you now is, for example, to give a quick round of the room to for us as GI enjoyer people, or at least GI interested people, to tell everyone if you are working on GI on something, what you can expect from GI in the near future. If you are working on something, or if you have some idea and you are looking for collaborators, I think that may be a very good opportunity to start collaborations. Otherwise, we can propose you, we can, yeah, basically just talk about what do you think GI is going toward, on what will happen in the future, what things you think are, yeah, what interesting thing will happen in the future, and what do you see GI going for? We don't actually have a real screen to write on, but I think Kevin will try to take notes. Or yeah, so yeah, so
Could I propose? I would be interested in following up my talk. I would be interested in if anybody would like to carry out experiments on mutating deep code. So I've got tools set up to deal with C++. Is anybody interested in trying to do something similar in Java, for instance? So simply take something which has got a lot of deeply nested code, throw random mutants at it, possibly generated by Magpie, possibly not, and see if you get the similar behavior or you get something radically different. I think either answer would be quite interesting and possibly easy to do. Dan has a question. Comment.
I definitely don't have time to work on it, but if you're looking for benchmarks in C and C++ of just like big code with lots of nested stuff, I've got I know there's a bunch of examples you can use. So if you've already got a pipeline set up, there's like 25 programs that are all, they're normally parsers, so they're that kind of thing, but they normally nest quite deep. And it might be interesting.
So part of the problem was a lot of the examples we work with are small, so something that's deeply nested is good. Anything else?
I will take that.
Other comments? Other things you would like to talk about? Dan?
I have one more.
Okay.
It might already exist for GI, but I work on fuzzing, and one of the things that is it not closer? Okay. One of the things there that I've seen is some guys did swarm optimization for selecting the right mutations to apply. So part of fuzzing is you apply mutations to an input rather than to a program. But one thing that was really quite effective there was it almost finds the mutation operators that are making the useful changes, and it focuses its time on applying those mutations rather than the other ones. It kind of, yeah, it optimizes which mutations are good. So I don't know if that's useful to GI in any way, but I thought I'd mention that it exists. If you think it's useful, you can ask me. I can point out the paper where they do it.
So which technique are they using? Hello? Okay.
Sorry. They're doing something called, I think, it's swarm optimization. I don't really know how that works. Seems like they have a load of separate things they do at once, and they converge on an answer.
Okay.
I can point out the paper. Would probably be more useful because I can't do it any justice. It's not really my area.
No, fair enough. Thank you. Yeah, I don't know the word, but I want to say that we've tried using reinforcement learning during the search to, promote those mutations that seem to be more promising for a particular program. So we've done experiments for program repair, and to be honest, hasn't worked really that well. I kind of have a feeling it's because of the the granularity of the fitness function, so either it passes the test or not. But we've also done some work more recently, which is not yet published, on runtime improvement, and we've tried, I think, 5 different RL algorithms, and in particular UCP has been quite fruitful in that regard. But as I said, it's unpublished, so I can't give you and experiments are kind of finishing now, so I can give you exact numbers of how well that's doing, but it seems to be working quite well for runtime improvements.
Okay.
Does that make sense?
Yeah. As I say, I just thought I'd mention it because
Yeah, thank you, because I haven't. So
I didn't know if
please
people
feel
had
free to
already
send me
done
the
it.
reference. Oh, Vesna, I see posted GI for specification repair.
Right. So what I am currently working on with the student is some kind of a repair of specification. So it's a bit different from program repair, but also quite similar because you have a language that describes that you can use to describe a specification, and that language also has operators. It has its own rules, and you can modify the specification, and you can break the specification, like it won't compile. You can make it realizable, non-realizable. So it's a bit different from repair, but I would like to try applying GI for the repair of the specification files that are not realizable. That's something that I'm interested in. So if anyone has any idea or anything, if anyone has any experience with the specification, I would like to hear their opinion.
What language are you talking about?
So I know about Spectra. That's what we have been working on. So it's a formal way of having specification files.
I'm not familiar with it. I am familiar with formal specification languages.
For example?
B, Z, ancient things.
Okay.
But something interesting about B, which is that it's actually a spectrum of probably, I sat calling it a spectrum is a bit over the top. I would say it's supposed to be a spectrum of languages which move from logic to implementation.
Mm-hmm.
But really it's more like there are a number of moves, but really there's a kind of loop-free logic stroke set theory. Then at the other end, no logic, no set theory, all implementation, sort of conventional high-level programming language. And in the middle, there's a mixture. So I guess that's where the spectrum comes in. So it's not as simple as, oh, you have a specification language, because it's designed to allow you to generate code starting from set theory-based logic. No doubt that's not what you're thinking about. Z, which is older than B, I mean, B is, I don't even know if anybody uses it anymore. I stopped working it a long time ago, but Z is actually a kind of weird formal language. I say it's weird because it's based on set theory, but it needs some other things apart from set theory. But I don't know what this the one you call it Spectra.
Right.
What's the nature of that?
So it is logic based. So I guess there's some similarities, but I'm not familiar with the languages you mentioned.
Okay, I'll tick. Why do you want to repair Spectra? It's for reactive systems.
Right.
I have a comment. I'm not sure whether this is the right abstraction level that you are looking for, but there is a formal specification language called Alloy. I think it can describe things like linear temporal logic and along the venue. And then there are a few existing work on applying automated program repair techniques for the Alloy specifications. I passed the URLs to one of the organizers. So if you can share that on the chat or something, that'll be nice.
Yeah, that would be helpful. Thank you.
I can propose another topic. So one thing that have been on my mind on at least 2 years now is the fear that the crave of LLMs just eat GI from inside out. So why not actually use LLM for what would actually be useful to us, besides using LLMs for GI or GI for LLMs? I think one of the worst hurdles that we have to go through every time is the manual step at the end, which is semantic validation on can we make an actual developer accept patch that are developing through GI? And LLM can do that, can explain code. I have seen LLMs to generate transformations or GI at the end of the LLM step to make sure it executes well. But we could try to add to use LLM to replace the human at the very end of the GI process to see whereas LLMs can actually explain what GI can do, because in the end, it's kind of a transparent box, but it's kind of a black box. We do transformation, but we do syntactic one, not semantic one. So maybe we could try to use Yeah, we could try to use LLM to see to make a step towards explainable GI, or at least to remove that one last manual step that we have to argue for in every GI paper. On at least for mine, that's always something that came up by reviewers. So, are you sure of what you are doing, or are you sure that it can be approved? Or maybe we could just use LLM to try to explain, or at least to try to convince the actual developers that the transformation we want to do to their software can be explained in more human terms than just we need to replace that stuff by that other stuff from the program.
Thank you. So regarding that, I'm curious if there is work on what developer expectations on GI is like. In my imagination, if you have a bit of code that is optimized for say execution speed, presumably a patch would be partially meaningful to the developer if it can if it's verified to reduce time. But as you said, it can be mysterious about how this piece of code actually achieves that goal. Because I have very little direct exposure to GI results, I'm not completely sure how confusing it is to developers. For example, some GI papers that I read say that some statements are deleted, so that's relatively straightforward, but there could be more complex patches as well. And so I think the core question is just how complex are the results usually, and what kind of explanations might developers usually be looking for? Do you have any idea?
I don't know if Vesna caught that. You have experience of APR.
Yeah, so we have a paper with a study from software engineers from Bloomberg, where they all agree that they would like to have a minimal set of changes, and to have very clear changes of the code. So whatever is transformed, they prefer very simple things changed in a minimal amount. So that's our findings from Bloomberg. So they're not interested in multi-location complex bugs to be fixed in APR, not at all. So they want to trust the fix and to easily review it.
I see. Thank you. So I have one question regarding that. So if they so even if you have a complex patch that's kind of well explained, they wouldn't like it that much. Is that your impression?
Yes. So if it requires a lot of time to review that patch, and even most of the time they wouldn't even be happy with just accepting the patch as it is. They prefer changing the small bits here and there, and then that would require some time. And then it's a question, would they be faster if they did everything manually, or reviewing a complex patch with a lot of their own changes? So kind of we were a bit disappointed by that, because we thought that they would go for more complex patches. That's what APR in research is trying to do, to provide more complex fixes. But at least according to those software engineers that we talked about, that's not what they were interested in.
I have one question. Is that study before Copilot got out, and before Copilot gets installed in every Windows machine from now on?
Yeah,
I think I'm seeing the field slowly going toward having most of the code automatically generated. So maybe that would be more inclined to accept it, or at least more inclined to accept it if they have some kind of explanation of why that change is provided or why that change is suggested?
Okay, that's true. I mean, in that sense, our work was outdated at that point. I mean, it happened before all LLMs and everything that happened in the last few years. So, okay, I said that's what we got from software engineers in Bloomberg, and that's what we got from like 2-3 years ago. So it might be already outdated.
But yeah, even if they like simple change, they might be inclined to accept slightly more complex change if it comes with a simple explanation.
Yes, they definitely want explainable fixes. They want to know where it comes from. They want to know why they're done. They would also like to know a person who can be behind that fix. So kind of not somebody they can talk with, like when you have a commit and then you have a discussion after that commit before the commit is merged into the main branch, for example. So they would still like to discuss with someone, even if that commit was actually done automatically. So that was also one interesting point. They still want a human to be behind everything. But yeah, maybe this trend has been changed in the last 2 to 3 years. And maybe they are accepting more automatic fixes and changes of code.
So a recent example, we got a pull request accepted, essentially because we're working on source code. We're not mutating binaries. We're not generating incomprehensible code. So although the pull request didn't make it in its GI form, it was understandable by the developers. Developers took it, rewrote it to their own satisfaction. So the GI was producing something which was useful to them because they could comprehend it. And that was in the last couple of months or so. And I think, yeah, I'm not sure how far the black box approach will go, but people at present are very interested in taking possession of their own source code. It's something that they feel personally attached to, and that's both a strength and a weakness for GI. It's a weakness in the sense of you're making changes to their property, but at the same time, you're making changes that in principle they can understand, and in practice often they can understand.
Yes, it's interesting what you're saying about that it's their property. So we also had a discussion about it's not just giving those fixes to, I mean, automatically generated any fixes. It should be they would be more acceptable if they are done to the recent code, and also there should be reviewers of those fixes assigned, and those reviewers should be actually the owners of the code. So we had a lot of discussion, like, then who is the owner of the code? If there are multiple collaborators, it's really hard to say who is the right person to review an automatically generated patch. And it's definitely one or many, all the collaborators on the code, because it is their code and they know it best. So they should be reviewing the automatically generated patch.
Does anyone has some other insight or some other topic to propose or to discuss?
Just a note, because actually this week one of our students will present the work exactly on the topic who's, well, not necessarily, kind of who's the right person. Basically, they've developed a system where an automatically generated patch is plugged into a current pull request. So a developer submits a pull request, and then an automatically generated patch, if it touches that part of code, it can be plugged in as a suggestion. So it's wrapped up. So it's all within the code review process. And then the person who reviews the patch is the person who's recently put a pull request. So hopefully, well, sorry, it's to be the usual code reviewer, right? So they're already supposed to be looking at that code. They so yeah, it's about the timeliness, and yeah, that goes to the right person. So we have a paper at ICSE on that precise topics, and that was our solution.
When will that be presented?
When? Thursday maybe. I'll post in the chat once I find it.
So we can simply go through awards, but we have still a lot of time if you want to continue discussing, or if you have anything to add or want to discuss or advertise, you can use that time to plug your conference or your future work. Feel free to jump in.
I'm still forming my thoughts about this, which is why my response was a bit late. But I regarding the question of who is the right person to review a patch, involving large language models, I wonder if it might be an interface issue. I heard of an LLM agent called Devin, which is a software, which is a LLM agent that kind of tries to imitate what a software engineer would do. And while I haven't used it myself, I hear that the interface is very similar to just talking to your colleague about what kind of code you want to have, and then Devin will do their best to actually implement it. And you can also ask of other requirements in real time. So if maybe if there's some kind of entity that is does not disappear whenever you turn off the chat screen, maybe that might help developers better accept automatically generated patches, because there's something that's not ephemeral that can quote unquote be responsible for a patch. But this is kind of, so yeah, so I'm just I'm not sure in any way, but I do wonder if it might be an interface issue. For me.
Yeah, I think in the end, software developers just want someone to be responsible, either themselves if they are really keen of their own code, or someone else, even if that someone is called Devin. But if it's just random code that is generated by a black box, they are not really that keen, because the responsibility will go back to them. But if they have some explanation, maybe they can just take the explanation and write the code themselves, write the fix themselves, rather than just taking it directly from GI. It might be just either an interface issue, the right way to convince them, or just not the right way to approach developers. Rather than a patch, they want to find the patch themselves. So maybe just an explanation on hints to how to get to that improvement may be better accepted. I don't know.
So
everyone-
one thing, oh, sorry.
Yeah, go on.
Yeah, so one thing we also discussed a lot was trust. Like, would you trust automatically generated patches? And the answer was kind of the tool would need to prove that it works well, the same way as software engineering showing to the others that their patches are good. So I think they had a comment like, well, we also don't trust every software engineer. So when we get a patch from them to review or pull requests, like we kind of we have confidence in some, we don't have a lot of confidence in others. So the same way as a software engineer needs to build that trust when they commit high quality code, they would ask that from a tool to kind of generate good patches and to show that those patches should be accepted. So they didn't really make a big difference between reviewing patches from software engineers versus a tool, because they want to trust both of them, and that trust has to be built.
So if everyone is fine with the discussion panel, we can perhaps move on to the awards. So we'll give 3 awards for the workshop: one for the best position paper, one for the best full-size paper, and one we just determined right now for the best presenter of today. Okay. So I will do that. So drumroll, the best research paper awards goes to Deep Mutation Have Little Impact by Bill Langdon and David Clark. I'm not sure if we have actually the award on papers. On paper. We do, yeah. So we will sign them afterwards, but so let's congratulate Bill for the best research paper. Doesn't work anymore. The best position paper award goes to, drumroll, ecosystem creation in genetic improvement of 4 emergent software systems, presented today by Salt Nemes, with co-authors Ben Rufford and Barry Pastors. So thank you for presenting the workshop. And determined by the audience today, according to the presentation, best presentation awards goes to, thank you, to everyone in the room. Maybe we need to reload or something. So the best presentation awards goes to genetic improvement for DNA security, presented by Kevin Lee. And we will fill it later. Yeah. So we'll send you my email. Oh. So let's thanks again every presenter that presented a little less good than Kevin, because Kevin is the best presenter, but let's congratulate them all anyway. So, and thank you everyone for attending the workshop. I think it was great. We will have the workshop again in the future, and I hope that everyone can attend again. So that was, if it works or not, yeah. So we can thank Shin again for giving the great keynote this morning. We can thank every author for submitting and presenting their paper. So we got every presentation, even though there was some issue with actually coming to Lisbon for one of the for the paper. We can thank the program committee and the program committee for doing all the reviews, organizing committee to wait for the other people from the committee to do stuff. We can thank the Field Guild to generative programming for sponsor this book. Profit from this book. Profit from this book. Thanking everyone that came to Lisbon today to attend the workshop, on people that connected online. We can thank Yonsuk and Somin, if I pronounce that right, for taking pictures in addition to the ICSE photographers, and Bill again to helping us organize the workshop and publicize in every mailing list for software engineering. So thank you everyone again. Thank you for the workshop. And there is a special issue on GI on the ICSE journal, and I think we invited all the papers. Yeah. So all the people that submitted a paper that were their people accepted in the workshop are invited to submit an extended version in the ICSE journal. And that's it. Thank you for attending. Yeah.
By the way, after he presented that solution paper, the paper next year was accepted. Okay, what actually works because we did that undergraduate had a background of operation research, he just wants to use the techniques.